Hi class, I'm here even on my sick day trying to get you all taught up and everything for tomorrow. So again, tomorrow for the last block I'm going to be observed. So again, try to be pretty respectful while she's here observing us. And other than that, let's go ahead and get started. So what we're doing today really builds a lot off of what we were doing with quadratics. So we learned how to factor quadratics, to solve them, and even graph them and look at some of the behavior of it. So what we're doing today is just building off of that knowledge. So my first example here, we're just going to go into examples for the most part of the day, is solving polynomials by factoring. So the first thing you have to do is get it factored down. What you're looking for is something that's familiar to you, that you know how to solve. So in this case, my original equation was 2x cubed plus 5x squared equal to 3x. So the first thing I do, kind of like I did with quadratics, is to move everything to one side. So I just subtract over the 3x to both sides, set it equal to 0 now because we subtracted it over. And then what I notice here is I have x cubed, x squared, and x. I don't actually just have a constant term. That's nice because what I can do with it is pull an x out of each of those terms, bring it out front. What I'm left with is 2x squared minus 5x minus 3 is equal to 0. What's nice about this is that you know how to solve and deal with these types of equations. So what's going to make that nice is one way to factor it, I chose to do it over here, is the tic-tac-toe method. So right here we're looking at a times c, which is 2 times negative 3 or negative 6. Then my b just goes down here, and I look for numbers that multiply to give me this and add to give me that. What I find is those numbers are negative 3 and negative 2. So I work my a over what's in the first quadrant, a over what's in the fourth quadrant out. That's just 2 over negative 3 and 2 over negative 2. That one reduces to 1 over negative 1. The other one doesn't reduce at all. So what I find when I write my factors are, I get x, which I just brought along. Then I have this factor, which relates to this, where it's 2x minus 3. And then this factor, which relates to the other one over here, x minus 1. From here, once I've gotten down to this really just about as far as it can get factored form, I set each of my factors equal to 0 to find out when that's the case. So first I just set x equal to 0. That's done. That's already a factor. 2x minus 3 equal to 0. What happens is I add over the 3 and divide by 2. That leaves me with x equal to 3 over 2. And then in this case, x minus 1, just add over the 1, and I get x equal to 1. So when I solve this polynomial out, I figure that x is equal to 0, x is equal to 3 over 2, and x is equal to 1. So those are my three factors. Okay? So let's move on to something that's kind of a little clever. Every once in a while we do something really clever in math that just makes our life easier. And this is one of those cases. So, in this case, again, we're just solving polynomials by factoring. If you look here, my equation is x to the fourth minus 3x squared equal to 4. So again, let's move everything over to one side. Like I did here, just subtract over the 4. And here's where my clever move's going to come in. I'm just going to decide that I'm going to come up with something called a. And I'm going to let a equal x squared. So what that does is instead of having x to the fourth, now becomes a squared. And of course, if I were to plug into that, that would be x squared squared. X squared times x squared is x to the fourth, which gets me back to where I am. So I'm doing this because it allows me to get a polynomial that looks like a quadratic. And again, we know how to factor these. In this case, it's really easy. You just look for numbers that multiply to give you this and add to give you that. That's just simply a minus 4 and a plus 1. So those are my factors. And what I do at this point is I come back and plug in my x squared. So I get x squared minus 4 and x squared plus 1 is equal to 0. Now, what's nice about this is at this point, x squared minus 4 is the difference of squares. We've learned that a difference of square breaks down even further to x plus 2x minus 2. That's how you deal. It's just a plus b, a minus b, where a and b are what's being squared. So x in this case in 2 squared is equal to 4. Okay? So what this leaves me with is all of this set equal to 0. I can't really break that down to factors any further, so let's set it equal to 0 and solve. So I get x plus 2 is equal to 0, and I just subtract over the 2, get x equals negative 2. Here I have x minus 2, add over 2, and that gives me x equal to positive 2. Then here's it's kind of a little string of working it out. X squared plus 1 is equal to 0. So I move the 1 to the other side, and this time I'm going to take the square root of both sides to get x by itself. So when I take the square root, we always say plus or minus when we're adding in a square root. And then just the square root of negative 1, we found out, we've talked about before, it's I. So my 4 solutions in this case, because it's a degree 4, like we've talked about, I get x equal to negative 2, positive 2, negative and positive I. So you can have complex roots when solving for these equations. That's perfectly okay. So on to our third board. Seeing we just talked about the difference of squares, we need to go ahead and talk about something called the sum and differences of cubes. Now the sum and differences of cubes, it's just when I have a cube subtracting a cube or a cube added to another cube, I can factor it down as such. So in this case, a cubed minus b cubed is equal to a minus b times a squared plus a times b plus b squared. And the same thing basically over here, just where does your sign go? Each of these has a negative symbol in it. It's just dependent on where it is. So for the sum, what's out front is a positive. Difference, what's out front is the negative. And then my negative shows back up in here. So a squared minus a times b plus b squared. So I've got the difference in sum of cubes. That's just a formula that we work off of, much like the difference of squares. There we go. Found the word. Anyway, so let's go ahead and just look at it kind of in action. So I have x cubed minus 27. So what I see here is x is cubed, and 3 times 3 is 9. 9 times 3 is 27. That's actually negative 3. So I need to keep that in mind. Now, that might actually change my problem too, and it will. So I said that my equation up here was a minus b. Well, if b is negative, that would actually make this a positive. So plus 3. And then again, I need to work my way down through here. So that one is just b squared. So my b was, again, negative 3. So it's positive 9 when it's squared. But I have negative 3 times x. So this needs to be changed to a minus. There you go. And then what I said to do here was solve from here using the quadratic formula. If you tried to use the tic-tac-toe method, what you're going to run into is complex roots, and we can't have those. So that's why we had to solve it using the quadratic formula. It'll be a lot easier that way. And then the same thing over here. So if I have x cubed plus 27 is equal to 0, well, that's 3 times 3 times 3, which gives me 27. So I don't have to change the signs here. You see the little small mistake there. So what I've got here is x plus 3. That's just my a is x, my b is 3. And then x squared minus 3x plus 9. And I set that all equal to 0. Now, when I say we're using the quadratic formula to solve this, we don't need to use it to solve that. You set that equal to 0, subtract over 3, that gives you x is equal to negative 3. What we're talking about is setting this equal to 0 and solving it. So, you use the quadratic formula for that. Again, you'll get complex roots. Okay? So, just kind of a little recap of what we're doing when we solve these problems. First thing you want to do is factor it down to something you know how to deal with. In this case, for you guys, that's going to be quadratics. So anything above something of degree 2 is something you want to get factored down. and that might not always happen, but if it does, you factor it down and then determine which method works best on the quadratic itself. You set each of the factors equal to 0 once you have it factored completely down. And then you solve for the solution. So that's also known as the roots. Make sure you're using that language. And then my big star here is if you can't factor it down to something familiar, you need to use a calculator. So I actually have a quick thing to go through with you on the calculator. So let me move all of these boards. Reveals kind of a hidden problem I wrote on the board. Okay. So this is my problem. What are the real solutions of x cubed plus 5 is equal to 4x squared plus x? So the first thing, every single problem is move everything over to one side. So subtract the 4x squared and subtract the x, get it all over to one side, and this is what I got. Next step, go ahead and pull out your handy dandy calculator. I'll move up close so you guys can see the screen. So when I turn the calculator on, I'm going to get this screen right here. Let's go up here or down here to graph, and then this is going to pop up. And I don't know why there's a graph already there, but we'll go with it. So what you're going to do is sit here and plug this equation into your calculator. So that's just going to be x cubed minus 4x squared. And it went and graphed it already without the rest of the problem. Minus x and then plus 5. And good. So I can go ahead and graph it. Here is the graph that I get. See that right there? And for some reason, it was nice enough to show me exactly what my roots were in this equation. So sometimes it's not going to be that nice. What you're going to have to do is go under here to Menu, Analyze Graph, and then there's a 0 button. When you click on the 0 button, it's going to be this thing where you have the line. The line needs to be to the left of where you see something crossing the axis. And then you press the center button, and then you move it to the right of where you see that. And then you press the center button. So it's already shown up here where my 3 roots are. That's probably because I worked it earlier. But we can go through and do that for each of the 3 roots we have here. And we'll know that it works out that way because I have degree 3 and my calculator gave me out 3 roots. So that means that it's giving me all the roots I should have. Okay guys, I will see you tomorrow. Hopefully I'll be feeling better. And again, last block, remember, on the best behavior. I appreciate you guys. I will see you tomorrow.